let's take a look at some examples involving linear inequalities. The first one, x is at least 5. Our goal is to write the solution set in set builder notation and in interval notation. Okay, so set builder notation looks something like this. There's a set of braces, and then we write whatever the variable is, x, and this bar, which stands for such that. So a value x such that x is greater than 2 would look like this. So if x is at least 5, that means that x is 5 or more. So I could write it as x such that x is greater than or equal to 5 in set builder notation. Okay, on the number line, I would graph a 5, shade it in, and then shade to the right. And this can help me get my interval notation. So lastly, interval notation, we start at 5, and then we've shaded all the way that the values of x approach infinity. So 5 to infinity, and a bracket at 5. Number 2, x is between 3 and 5 inclusive. Okay, in set builder notation, we have our variable x such that x is between 3 and 5, so we have 3 is less than or equal to x is less than or equal to 5, and I put equal to because it says inclusive, so that means include those endpoints. Okay, on our number line, we would shade between 3 and 5 and include them. And then lastly, our interval notation would be bracket 3, comma 5, and then closing bracket. Another way to write this compound inequality is x is greater than or equal to 3 and x is less than or equal to 5. If we graph each of these on the number line and find the intersection of the two sets, then we can see the numbers that are in both of these intervals at the same time, which should be our solution. So x is greater than or equal to 3 would be shading 3 and to the right. X is less than or equal to 5 would be shading 5 and to the left. And you can see this region in the middle where these lines would overlap, which is from 3 to 5. Okay, number 3, we want to write from the number line what this set is in set builder notation first. Okay, so we see where exactly is shaded, which is between two numbers. And we always write our intervals from smallest to largest. So we start with the smallest number first, -5, and then we're going to put our x in the middle and 4 on the right. Then we just have to get our inequality symbols correct. So on the left, we see that this -5 is shaded in. So we're going to have less than or equal to, but the other 4 is not shaded in, and therefore it's just going to be a less than. All of the time, as long as your smallest number is on the left and your largest is on the right, every time these symbols should be less than. So they should be pointing the same direction. The only question that you're going to have is whether to include or not include that endpoint. And then to write this in interval notation, we have a bracket on the left, -5, comma 4, and parentheses. And number 4, we want to write the interval of x values within or including a distance of 3 units from the number 1. Okay, start by labeling a 1 on the number line and then count 3 units on either side. And we're going to shade between -2 and 4, inclusive. Okay, so that makes it pretty easy to see what the interval notation will be, which is from -2 to 4. But another way to write this from the start is that we have the distance between 1 and a number. So the distance between a number and 1, we could write that using absolute value, is less than or equal to 3 spaces. So less than or equal to 3. And then if you think about rewriting this inequality as a conjunction, we'd say x minus 1 is less than or equal to 3 and greater than or equal to -3. And then add 1 to every side. So we're left with x is between -2 and 4 inclusive. Okay, let's take a look at just a few more examples. This next problem, we're going to try to simplify and then isolate x and then write our answer in interval notation. Okay, so the first thing is to distribute. So distribute -1 to both terms inside the parentheses. And we get -x minus 5 plus 5x is less than or equal to 6x minus 2. And just like an equation, the next step is to combine like terms. Okay, so we're going to combine the -x and the plus 5x. And we get 4x minus 5 is less than or equal to 6x minus 2. At this point, we move the x's together and the constants together. So to move the x's, I'm going to subtract 4x. And at the same time, to move the constants, I will add 2. We're left with -3 on the left is less than or equal to 6x minus 4x or 2x on the right. And then lastly, divide both sides by 2, the coefficient of x. So we have -3 halves or -1.5 is less than or equal to x. Now I tend to want to write the x on the left, so we're going to just take this entire thing and flip it over. So x, notice how the greater than symbol points, so the larger part of the inequality points toward x, so it should still point toward x. X is greater than or equal to -1.5. So if we draw a number line, -1.5, we're going to shade to the right and shade in -1.5, and now we can easily write that our interval notation is from -1.5 to infinity. Okay, next example, the absolute value of 2x minus 3 is less than or equal to 11. Okay, so we have 2 rules for our absolute value inequalities. And the first part, no matter which rule you use, you want to make sure the absolute value expression is isolated, which it is. Okay, so now we're going to just decide if we're going to use a conjunction or a disjunction. So is this an and or an or problem? And I can tell based on the direction that the inequality is flipped, and this one is less than or equal to, and therefore we're going to write a conjunction. So we write it as 2x minus 3, and the right hand side looks pretty much identical, just no absolute value. But then we fill in the left hand side by writing another less than or equal to and a -11, the other sign, so the opposite sign of the given value. And we solve this inequality. So the goal is to isolate x. We're going to first start by adding 3. And when we do that, we have to add 3 to every part. Okay, and we have -8 is less than or equal to 2x is less than or equal to 14. Next, divide by 2. And we have x in the middle is greater than or equal to -4, and at the same time, it's less than or equal to 7. And this is it. This is our answer. You could write it in set builder notation officially by writing the x and the bar. But lastly, we want to write it in interval notation. So if I were to shade on the number line, we'd be shading between the -4 and the 7. And therefore, the interval notation is going to be from -4 to 7 with brackets. And lastly, number 7, the absolute value of x minus 3 plus 3 is greater than 8. Okay, so before we start, we need to isolate the absolute value expression. We're going to subtract 3. We're left with the absolute value of x minus 3 is greater than 5. And because this looks more like the second absolute value property, we're going to write a disjunction instead, or an OR problem. In the first part, it looks pretty much identical to the given inequality. So x minus 3 is greater than 5, just no absolute value. Or, and then the other one looks almost identical, at least at first, x minus 3, you're going to flip the inequality and change the sign. So is less than -5. And now just solve each of these and then combine your answer. Add 3 to each side of the inequality. And we're left with x is greater than 8, or x is less than -2. So imagine graphing these intervals on the number line. X is greater than 8. We're going to shade to the right of 8, not including 8. Or x is less than -2. We're going to shade to the left of -2, not including -2. And we have 2 intervals that we're going to have to write down and combine with a union symbol. So altogether, our final answer is from -infinity to -2 parentheses, union, 8 to infinity.